Hello, everybody, and welcome back to another video lesson, 7.2.5 in the 8th grade book. That is Core Connections 3 book, Proportional Equations. There's a few things you probably know about proportional equations. It has to start at 0, 0 on the graph. And there's a strict relationship in terms of the growth. It's constant. So let's say 7-77. Mr. Mears is running for mayor of Atlanta and wanted to do some polling to find out how many people would vote probably for Mr. Mears. Obviously, people lie, and it's never actually correct 100% of the time. But they called 100 people, and they said 68 said that they would vote for Mr. Mears. Now, if they called 50 randomly, predict how many would you think would vote? Well, if they did 100 to 50, then that's half. So I would do 68 to 34. And that's what I would say. I would say 34 people, to be honest, because you're just splitting it in half. Do you suppose that this is proportional? Well, I think so. Well, this right here is. Right here. So if I did 100 to 50, then it's 68 to 34. That is proportional. I didn't change any different numbers. I just cut it in half. So if I said 200 callers, what would that be? Well, then 200 callers would be double of 68, which would be 136. So that is proportional within itself. So yes. Next one. Karina's neighbor has 327 potential voters. If voting in her neighborhood is similar to the poll, how many neighbors will probably vote for Mr. Mears? Complete the table below. So let's go ahead and scroll down here and clear the section. So we have 50 to 34, 100 to 68. Well, what would 327 be in terms of y? Well, let's take a look at this. If I do this in proportion, so 68 gives me 100. Now, again, change of y, change of x in a situation like this. So what would y be for 327? Now, that's kind of like what I would do in terms of find out the proportion. And so 68 out of 100, what would y be? Well, how do I get from here to here? That's going to be 3.27. You're multiplying. So times 3.27 here, that would be proportional. All right, so it's like a giant one. So what is 3.27 times 68? I'm going to go ahead and 3.27 times 68. That's going to be 222.36. Now, you can't really have 222.36 voters. So you can either round up or round down what you think is going to be the best guess, because obviously this is a odd number and it's not going to go evenly. So I would say you can probably round down to be safe. Worst case scenario, 222. Or if you give me a reason that you would round up because this is over 222, that's totally fine as well. So either way you explain it, that's what I would say. Make a graph of the data they have collected. Draw a line through the point. Should your line go through the origin? How do you know? All right, so let's go ahead and do that. Let us get some graph paper. Let's see, printable graph paper. And let's do waterproof paper. And let me just go all, and there we go. Online graph paper. Can we just, I don't want dots. I don't want, okay, game on. Free graph paper. Printable paper. There we go, that's better. Yes, we want this one, that's fine. Yep, click it, there we go. Oh my goodness. Download for free then. Oh my goodness. Why won't you just download? Start download manually. Thank you. Appreciate it. Oh my goodness, it's so big. The squares are so big. Okay. Printable graph paper. Print free graph paper. This is good. Start. There we go. Okay. I don't know why it took so long. Thanks for joining me in this adventure of graph paper. Make a graph and draw a line. Okay, so we have 50, 100, and 327. So that's gone. How would I do this? Let's say I would make this, let's use black. Let's skip one. So that will be 327. That's kind of a lot. So let's skip a line. 3, 4, 5, 6, 7, 8, 9, 10. 25, 50, 75, 100, 25, 50, 75, 200, 25, 50, 75, 300, 3. I'm going to make everything 25, 50, 75, 100, 25, 50, 125, 150, 175, 200, 225, 250, 275, 300, and 325. And then our X, or Y, I should say, 3468, 34. Let's make this 34. So let's make it by 3468, 3468, tens, 10, 20, 30, 40, maybe 10s. We go 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Well, I have to get to 200. So that doesn't work out. I need to get to 200. So let's make it by 50s then. Or 25s as well. Let's see, 25, 50, 75, 100, 25, 50, 75, 200, 20, oops, 25. So 225 is up there. 25 is up here. All right, I think that'll work. So let's go ahead and graph, draw a line through the points. 50 and 34. So let's use blue. 50 and 34, that's going to be, let's just say there. So 50 and 34 is 1. 168, 25, 50, 60. Let's go 68. Well, maybe it's a little bit. Let's do 50, 75, 68, close to 7. Let's make it that right there, not there on the top dot. And 327 is 222. 325, so a little bit past that, is 222. All right, so that's my points. Make a graph, draw a line. Should your line go through the origin? So when you're doing a graph, it should go through the origin, which is 0, 0. So if we have 0 number of potential voters, that means we should expect 0 votes. So that's why we want to do it from 0. So here's my first point. I'm going to draw a line. It looks something like that. Going to give that the best shot I can get. And what is the equation of the line in y equals mx plus b form? Don't close out of this. Got to be very careful. Let's go ahead and use orange. So I would say, did I cross any line? This looks like a good point, but I probably should use more so like this point. But I'm just going to have some fun. I'm going to go up and over right there. So that's 25, 50, 75. So between 100 and 75, that would be straight in the middle. That's going to be 80, 87.5-ish. And then this one would be 125. Split this down the middle. What is 275 divided by 2, just for fun? That's 1, 3, and then 115, 7, and 5, I believe. 137.5, 137.5. So that is our y over x. And yeah, so 87.75 and stuff like that. So I would do probably a better one, just to be honest. I would just do this point that I have right here, which is 68 over, over 100. And that would be kind of my similar guess. So 68 over 100, that would be my line. That's growing. What would that be in terms of, so let's divide that by 4, divide by 4. That's going to be 1. So that's 25. So 68 divided by 4. The reason why I'm dividing by 4 here is just because I know that this is divided by 2 easily, because that's going to be, for example, well, I'll just do that. So that's 34, and then divided by 4 here, or 2 again, would be 17. Oh, there it is. So 17 divided by 25, that would be my slope or my growth. Because I know that because I'm starting at 0, 0. So 0, 0, the change from 0 to 68 and the change from 0 to 100, and that's going to be 17/25. So that would be so y equals 17/25 x. And that would be my answer because it starts at 0, 0. Use the equation to figure out how many people will probably vote if 3,500,000 people voted in the election. Wow, that's a lot. What do x and y represent in your equation? Okay, this is a great point. So remember, this is our x and this is our y. So if we were to label this, which I didn't label this, x is the potential voters. So this is potential voters. And our y here is going to be expected voters. Expected voters. My handwriting's sloppy right now, so I'm sorry, but as long as you know what we're doing. Use the equation to help Karina figure out how many people. So 350 is people vote in the election. So that's the total. How many people will probably vote if we have 350,000 total? So that's 350,125 is our total, equals 17/25 x. And so what we want to do here is we want to solve. I solve by multiplying by 25 divided by 17. The 25s would cross out, the 17s would also cross out, so I'm going to multiply this by 25 divided by 17. And so basically what you can do is you can do 25 times 3,500,125, which is 8,753,125, and then you divide that by 17, which is 514,000. Close. 540. Wait, that doesn't make sense. Why does that not? That makes no sense at all. 514,889. No, that doesn't make sense at all. Let me restart this. Let me go ahead and clear this up. All right, let's try one more time. I apologize, everyone. All right, use the equation how many people will probably vote if that many people vote into the election. Okay, so let's go ahead and use the equation. So we have y equals 17/25 x. All right, and so let's see how many people will probably vote. So again, x is the number of potential voters, y is the number of the votes expected for them. And so give me just 1 second. Okay, and so these are going to be the people in the election. So it's actually not the total. This one is actually going to go into how many people are actually voting. 17/25 of the potential voters are going to expect. So this is expected. And then the number of potential voters, the potential is here. This is the total voters we're going to put there because this is what we expect in return. So I just inputted my stuff because I was like, why is my number bigger than the total number of voters? So 17 divided by 25 is 0.68. And then you times that by 350,125. That is 238,085. All right. So you plug that in. So 0.68 times 350,125 equals y. And y equals 238,085 potential voters. What do x and y represent? X and y represents there. What information would the unit rate give Karina? So Karina's rate is pretty much for every 25 voters, 17 vote for Mr. Mears. All right. You can also say this. You can also say, so 17 out of 25 equals 0.68 voters for every one votes for every one voter. So again, for every one voter, they have a majority of the votes, which is going to be 68% in terms of that. So you can expect the unit rate is this, or 17/25. So 0.68 expected votes out of the potential voters. And that's what you would do. Yeah, so the unit rate, the key here is you want your unit rate to be out of 1. That's how you find the unit rate. So just divide it by 1 or put the 1 at the denominator. All right. Let's see. In 2 minutes, Stacey can write her name 17 times. That's pretty fast. Use the proportion right equivalent ratios to find out how long it will take her to write her name 85 times. So 17 times in 2 minutes. That's equal to, for example, how many 85 times in X minutes. All right. So basically you want to figure out how you get there. So we can figure out this 2 ways. 1, 17 goes to 85, and then that will give us how many times there. If that doesn't work, then you can also, if that doesn't work, you just solve by solving for X. And here's the tricky part. You want to cross multiply. The shortcut way is going to be 17x and 2 times 85, which is going to be 170. And then you divide by 17. All right. Again, that's a shortcut way. What I'm really doing is multiplying by the reciprocal. So I'd multiply this by, for example, x divided by 85. And then I multiply this one by x divided by 85. And then I would multiply this side by 2 divided by 17. And then 2 divided by 17. And then you would get all your stuff that would cross out, in a sense. Yeah. So I'm going to go ahead and clear that up. That is going to be 17. No, sorry, not 17. It's going to be 10 equals x. I deleted everything. So let me write that up again. 17 times in 2 minutes. So 85 times in x minutes. And then you cross multiply. So 17x equals 170. And then you divide by 17 on both sides. X equals 10. Right there. Make a graph of this situation. What piece of information is on the dependent axis? So one thing you need to know, dependent. So there's a graph here. One depends on the other. Why? And I think of it like as like a stick. So a stick, if it depends on something to keep it stable. So this depends. Why? Or else it's going to fall over left or right. So it depends on everything here. This is independent. Flat, you can leave it flat all you want. So it's completely separate. This depends on something to stand upright. This doesn't depend on anything. That's how I remember it. So anyways, what piece of information is on the dependent axis? Well, we know that we have time. Oh, not time. Where is it? 2 minutes. And this is time. And time is usually x. So that means 85 times is the write her name, and 17 times write her name. That is going to be our dependent axis. The amount she writes her name. All right, make a graph of the situation. I'm going to make it real quick. I'm just going to do this. I'm not going to do the graph. Let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 right there. 2 to 5, 10, 15, 20, 25, 30, 35, 40, all the way up. So we have 2 minutes, 5, 10, 15. So that would be like right there. And then for 10, it would be all the way up there. So it would be like that. But yeah, basically draw a graph. This is the dependent. 10 minutes is the total amount she writes her name. I'm just going to go very quickly because I don't want this video to go too long. We're at 19 minutes. So forgive me for that. Another name for slope in proportional algebra is constant of proportionality. Find the constant of proportionality and write an equation. So we already know y equals mx plus b. Our growth here is going to be 10. Well, actually, we don't know what our rate is. It's actually 17 divided by 2, which is going to be 17 divided by 2 is 8.5 over 1. So that means y equals 8.5x. We know that b is going to be 0 because it starts at 0, 0. Because in 0 time, she writes her name 0 amount. And so all I did was take this rate and do it for 8.5. And that's kind of what I did there. Yes, so using the constant proportion. What does X and Y represent in this situation? X equals time in minutes, and Y equals the number of names written, number of names written down. I think that's the best way to do it. The number of times she wrote your name, something like that. What is the advantage of the equation in part D compared to the proportion? Let me go ahead and clear this up. What is the advantage of the equation in part D compared to the proportional relationships in part A? What is the advantage? Okay, so the first off, the advantage of the equation, you can instantly plug in and find out any amount of numbers. So with y equals 8.5x, you can instantly find out, well, what if she did it for 100 minutes? You can find out how many times she can write her name. If she said, what if you want to say, well, how long will it take her to write her name 100 times? Well, then you would just plug in 100 for her total and then just divide by 8.5. So again, this is the total number of times. If I said 100 times, or if I said the minutes. So for example, if I said how many times for, like, let's say 50 minutes, how many times can she write her name? Then you just plug it in. The advantage of proportion is just something that you can do really quickly for a specific situation. So like 8.5, 17, double that for 34. You can just kind of do it really quickly. What is the unit rate at which she can write her name? Again, so as I said before, it is 17 divided by 2. So this is 17 times per 2 minutes. And then you can make that into a decimal, so 8.5. So 8.5 times in 1 minute, or you can put that over a fraction of 1, and then you can figure that out pretty much too. So as long as it's over 1, you're going to be pretty solid. And that's it. All right, let's wrap things up. Hope you have a great day. Good luck on your homework. Let me know if you need anything. I will talk to you all soon. Bye-bye.